Welcome to Talking Science, where we dive into the latest science and space news. Today, the project scientist on NASA's OSIRIS-REx mission is back. Jason Dworkin, thanks for your time.
Thanks for having me.
Jason, a huge milestone achieved this week with the successful full-throttle burn of the main engine to bring the spacecraft home.
Yes. So it was yet another perfect maneuver by the OSIRIS-REx spacecraft and the OSIRIS-REx navigation team. The spacecraft did a main engine burn to depart the region of Bennu, and it's on the way back to Earth.
It is very exciting. Now, it's going to take 2.5 years to get here. And what I find incredible is that you already know when and where it will land. Obviously, some pretty serious maths goes into those calculations.
Oh, the flight dynamicists are remarkable in what they can do and the information we get back from the Deep Space Network on the Doppler ranging. So they actually take into account all objects in the solar system, even the gravitational effect of Mars and the Moon, Pluto. It's all factored in there. It's really amazing what they can do. In fact, the location of the landing, the biggest unknown is the weather in Utah on the landing day.
Well, for something that's 2.5 years downrange, that is absolutely incredible.
Now, to be fair, we do course corrections the entire way through. It's not a main engine burn and we're done. Main engine burn sets the spacecraft in the vicinity of Earth, and then we tune that as we go along. That's just a whole lot easier, and we have lots and lots of time and schedule for cleanup burns, just to adjust things just a little bit if necessary. That's how these are all done. All the spacecraft missions you hear about, there's some wiggle room in there to make sure it's perfect.
It is incredible to think that everything is factored in ahead of launch and exactly what it's going to be doing, each of those mission parameters, how it's going to get there and how it's going to do that. And then equally as impressive, on the fly calculations can be done, as it were, to course correct and make sure everything's pitch perfect. Just an incredible feat of engineering in all of that.
Indeed, although it's not quite on the fly. We have, as you said, 2.5 years. And so we get the data, we spend a few weeks doing calculations, double checking, triple checking, making sure everything's right before we send the command up. That's how you don't make mistakes.
So will OSIRIS-REx orbit the sun twice inside of Venus's orbit, then line up with Earth and release the sample capsule for the re-entry to the Utah desert in September 2023? And how much material did she manage to capture?
So first of all, the spacecraft doesn't go inside the orbit of Venus until after Earth flyby. We need to keep the sample cool and pristine. And so the trajectory that takes the spacecraft to Earth means that after Earth, the spacecraft doesn't matter so much. And so it does pass within the orbit of Venus a little bit. And hopefully the spacecraft will survive that and be ready for future exploration. As far as how much sample, we have estimates, and there's a range of numbers you can use. If you remember, the sample container was literally overflowing with material, and the mechanism we had to weigh it was by sticking the arm out and rotating the spacecraft and measuring the change in moment of inertia. But doing that actually would force material out and be lost. So we'd get a mass, but in exchange we'd lose material. And in this case, it's better to have more sample and less knowledge. And so we decided to stow the sample as quickly as we possibly could. And that was harder than it sounds. We actually had to negotiate with other space missions to get them to give up their Deep Space Network time so that we could communicate with the spacecraft, because the actual loading of the sample into the sample canister, that's ground in the loop. So you take a picture of it, you move it a centimeter, you wait 16 minutes for the data to go to Earth and then back again, and then you move another centimeter. So it was an agonizing procedure. So we were grateful to the other missions that has said, okay, yeah, we'll wait a few days until we get our antenna time.
Well, Jason, how successful was the phase of the mission of orbiting Bennu and collecting the sample?
The sample canister was literally overflowing. We don't know the amount. Certainly well above the 60 grams that's required to achieve all of our science goals. We saw material leaking out, so it's not full anymore. So it's less than the 2 kilograms of capacity. So half a kilogram, kilogram and a half. It's really hard to say. We can speculate we can place bets if you want, but we won't really know until it gets into Houston and we open up and weigh it. And we'll just be patient.
The really fascinating thing I found as I started to pay more attention to OSIRIS-REx during the re-entry of Japan's Hayabusa 2 in December was that half a kilo is plenty of material to do the experiments we can think of now and save some for the future as well.
Well, yes and no. So we are preserving 75% for the future, so that your viewers or your viewers' children or grandchildren can make life choices to analyze the sample and ask questions of their own. But part of the nature of these sorts of analyses is you can always ask deeper questions that look at more and more subtle compositions, and that takes more sample to analyze. From our observations at Bennu, we see that there are multiple lithologies. And so our calculation of that we need 60 grams to answer our science questions, that was based on one monolithic type of material. We have several that we've identified from orbit. And so that would be 60 grams of each one we'd like. And of course, as I said, if you want to know the chemical composition, that takes some mass. If you want to know the isotopic composition of those chemicals, that takes more mass. If you want to know the isotopic composition of those chemicals precursors, that takes even more. So it depends on how far down you want to drill. So it is true you can do amazing work on just one particle as far as the mineralogy and counting atoms and things of that sort. When it comes down to some of the more complicated compounds, like the compounds of life, our techniques aren't as sensitive.
Well, we saw with Japan's Hayabusa 2 that it now has an extended mission to continue researching. Is OSIRIS-REx in a similar position once it drops off the sample to Earth?
OSIRIS-REx left Bennu in very good condition. We were actually concerned that the radiators could have been covered in dust, star trackers obscured, the solar panels covered in dust and not able to function properly. They're all in great shape, which is actually why we did the final flyover of the sampling site, take another look at it. There is obscuration of some of the instruments, but nothing that actually impedes anything, as you can see from the flyby images of Nightingale. So there's a whole process where we can write a proposal to NASA, and they can decide if it's worth the budget and is worthy science. And it's still in negotiation how open competition that will be. And so we will follow the direction and find out what works.
Jason, 2.5 years to re-entry. Is it now sitting back and waiting, or are there still plenty of things to be done?
We're doing rehearsals on the recovery of the sample return capsule for both the nominal case and the off-nominal cases. That you can always come up with things that could go wrong, and we practice that. We are, of course, exchanging samples with JAXA for Hayabusa 2 samples. And so we'll be some of our team members, including myself, are working on Ryugu samples. And so we use that information to help inform us how to analyze Bennu samples. So much to do. It's going to be actually a busy 2.5 years.
Jason Dworkin, project scientist for NASA's OSIRIS-REx mission. Thanks for beaming in. Good luck with the return voyage.
A pleasure. Thank you for having me.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favorite podcast app 5 days a week. Just search for Trekzone and subscribe.